Hello friends, welcome to Concept Clarity Tutorials. So far we have covered about trigonometry, we have seen equations. So we're going to see further about trigonometry. In the last video we have covered trigonometric ratios and we have covered it mostly for acute angles. Today we are going to cover for general angles. Trigonometry ratio for general angles. Ratio for general angles. This is the topic we are going to cover in today's session. So earlier we have covered trigonometric ratio for right angle triangles. That means these angles were actually acute angles. So we have studied what were the values for the sine values for the different angles, right? And this is the acute angle. This is also an acute angle. So we have studied the values for this particular angles, acute angles. So now we are going to study for general angles, all kinds of angles. Okay. So as you know, trigonometry is not limited to acute angles. We can consider any other angle as well. So we're going to study it. We are going to see how we can derive those ratios as well. So I'm going to wipe this out. Let us consider a coordinate system. This is a coordinate system. So this is the first quadrant. This is the second quadrant, third and fourth quadrant, right? Now using this coordinate system, we are going to derive the trigonometry ratio for the general angles. Okay, so I'm going to wipe this out. So I'm going to take this coordinate system now again. In this coordinate system, if I draw a circle around, this is a circle, and I draw a line subtending from 0 comma 0 all the way at a distance of r, and this is making an angle theta. Okay, so I draw a perpendicular to the axis, to the x-axis. I draw a perpendicular, and this distance is called as y, and this distance is x. So now we know for this particular coordinate system we can write sine theta is equal to opposite by hypotenuse, y by r. We can also write cos theta is equal to adjacent, that is x by r, and tan theta is equal to opposite by adjacent. This is what we have studied in the previous session. So now here all the values are positive, right? This side of the axis is positive. This side of the axis is also positive. This side is negative. This side is negative, right? So now, so we know the values for this. For sine theta, if it is on the first quadrant, this is the first quadrant, the value of sine, cos, and tan are these, and the signs are all positive, right? So now there can be an angle on this side of the quadrant. If I extend a line here, and the distance, this is all also equivalent distance called x, and this height is y. It's just a mirror image of this particular triangle. The left hand side, that is the second quadrant triangle. The second quadrant triangle is a mirror image of the first quadrant triangle. But now if you notice, this x will take negative values and this y will be positive values, right? So if I want to find out, if I want to find out, this is the new theta. This is the new theta now. So let me draw a fresh diagram. So I'm just going to follow up on the same concept. I'm going to fresh slate. Okay, I'm going to wipe this out. I'm going to draw a circle again. Okay, what we did earlier was we extended a line here and we saw that this was theta, right? So now I'm going to extend another line here and I want to measure sine of this angle. This full angle from here to here is going to be, what is this angle here? It's going to be theta. Okay, let's assume this is theta. So this angle here is actually 180 minus theta. This is y and this is x. This is positive y, this is positive x. Now here y is positive because it's on the upper side, and here x is going to be negative, right? Because on the left hand side from 0 comma 0, right? So now what is going to happen? So now if I want to write sine of 180 minus theta, it will be equal to plus y divided by, and r is always going to be positive, right? Plus y divided by plus r. Cos of 180 minus theta is going to be minus x divided by plus r, and tan of 180, sorry, this is 180 minus theta, 180 minus theta is going to be equal to opposite side plus y divided by minus x. So here if you see, cos has taken the negative sign and tan has taken negative sign as well. So now we also know that 180 minus theta is nothing but the mirror image of the first quadrant. It's a mirror image of the first quadrant, just that the sign has changed. So we can write now that sine of 180 minus theta is equal to positive, positive sine theta, if this was theta. And sine, not sine, cos of 180 minus theta is going to be equal to, this is negative, right? This is negative. So can I write here minus cos theta, right friends? Right students? So then I have tan theta. Tan of 180 minus theta is equal to minus tan theta, right? This for the second quadrant angles. This for the second quadrant angles. Now if I want to find out the value of, let us say theta is 120 degrees, which is an obtuse angle. Now if I say sine 180 minus 120, I can write this equivalent to sine of 120, right? But sine of 120 is equal to sine of 60. It's a mirror image, right? This is the mirror image. 180 minus 120 is 60. This is the mirror image what we saw here. So sine of 60 is how much? Root 3 by 2. Likewise, you can do for all other all other ratios as well. Let us take one more ratio. Let us take cos. Cos of 180 minus 120 will be equal to minus cos of 120. But cos of 120 is like nothing but the mirror image of 60. So you continue to write the minus sign, continue to put the minus sign because in the second quadrant, and you say cos of 60, which is half. So I hope this is clear. This is for the second quadrant. The first quadrant basically theta is for the first quadrant, for this quadrant, first quadrant. Let me write it on a fresh slate. So you can just note down this first. I can write it on the fresh slate. Here theta is greater than 0 but less than 90 degrees. And here theta is greater than 90 degrees, but it is less than equal to 180 degrees, right? Equal to here as well. Here what will be the case in this quadrant? In this quadrant what will be theta? In this quadrant theta will be greater than 180 degrees but less than equal to 270 degrees. Am I right? And then in this quadrant theta will be greater than equal to 270 degrees and less than equal to will you write 0 degrees or will you write 360? We have to write 360 degrees. You remember 360 degrees. So now for this quadrant, we have seen for this quadrant, we have seen for this quadrant, we have seen that sine, tan and cos are all positive here, right? Here sine turned out to be positive, cos turned out to be negative, and tan turned out to be negative. So now we'll see for the third quadrant. So let us draw it for the third quadrant. For the third quadrant, let me take a circle first, become easy to understand. I'll extend the line here. Now this angle is theta, right? And this extension from the height from here to here with this line, this is called y. Okay, this will be negative y now, and x-axis will be negative. Uh, Ignore this, negative x, and r will be positive r, right? So now what can I write? Now how to find out all the ratios of sine, cos, and tan? Can you take a minute and try yourself? Can you take a minute yourself and try? So here if I have to do, what will I do? Tell me what will I do? So this triangle here is the mirror image of this particular triangle which we already had of y and x, right? So this angle, this full complete angle here, whatever it is making from here to here, instead of calling it theta, can I say 180 and this is theta? Can I say 180 plus theta? This is theta and this is 180. I'll say theta dash is equal to 180. So this complete angle from here to here is actually 180 plus theta. So to write down here, I will write sine of 180 plus theta is nothing but sine theta because the same is the same triangle, right? Sine theta. But is this value going to be positive or negative is what we are going to see. It is what we need to check. So sine theta is basically it will be minus y divided by plus r. So here now we got it as negative, right? Now we have cos. Cos of 180 plus theta is equal to cos of theta, and cos of theta is minus x divided by plus r, which turns out to be negative. Now tan of 180 plus theta is equal to tan theta. We can write it as minus y divided by minus x. This is turned out to be positive. So now actually the value should be, this is positive tan theta and this is negative cos theta and this is negative sin theta. This is how we are supposed to represent. So just to summarize here, I'll summarize it here. So I'll have sine 180 plus theta is equal to minus sin theta, and cos of 180 plus theta is equal to minus cos theta, and tan of 180 plus theta is equal to tan theta. This is positive. So here we see that sine is negative, cos is negative, and tan is positive. So here all were positive, all positive. Here, here sine was negative. Here tan turned out to be negative, and here finally it's actually cos which is negative. Okay. Sorry, I did sine is positive, right? Sine is positive, tan is positive, and cos is positive. Earlier, sir, what happened to you? Did you have breakfast or no? Sorry, students. Sorry, my mistake. Instead of considering that it's supposed to be positive, I consider it as negative. This is all positive, sine positive, tan positive, and cos positive. Okay, I'm not going to do for cos again, or okay, let's do it for cos as well. Let us do it for cos. I'll take the triangle little on the left. It becomes easy to write this side. Okay, so this is the circle. This is the angle subtending where theta is less than 360 but greater than equal to 270, right? So here this is y. This is going to be negative y, and this is positive x, and this is r, of course. This is positive r. So now here I will write it another way this time. So here I can say sine theta is equal to, this is theta, sine theta is equal to minus y by r, right? Minus y by r. So this turned out to be negative. Cos theta turns out to be my positive x divided by positive r. So this is positive. So now we see here it's positive. And tan theta is equal to minus y divided by plus x, right? Opposite divided by x. Okay, which is negative. So we can write finally that sine of what? 360 minus theta is nothing but minus sine of theta, right? Cos of 360 minus theta is equal to positive cos theta, and tan of 360 minus theta is equal to minus tan theta. Okay, this is the summary. So I'll just give a summary now. This is what how you're supposed to derive what are the values in terms of sine for the various ratios. Okay, these angles are greater than the acute angles. Okay, so let us proceed. We'll summarize it. So this is your coordinate system. Here you have sine, tan, and cos as positive. These are all positive. Here the first one is positive, second one is positive, and the third one is positive here. So this is how you're supposed to remember. Okay, now what if theta is more than 360? If theta is greater than 360, then what happens? Can we say when theta is greater than 360, can we say theta is equal to 360 plus 5, the additional angle? So we can say that sine of theta plus sine of theta is equal to sine of 360 plus 5, right? Because it lies in the first quadrant. We are assuming that it goes this way. It goes all the way like this onto this side. It goes on the first quadrant. So if it is in the first quadrant, sine, cos, and tan are positive. So sine cos of theta will be then cos of this is the additional angle phi. So instead of theta, actually it should be phi. Okay, here it should be phi. Okay, cos of it will be 360 plus phi, and here it will be tan of phi is equal to tan of 360 plus phi. This is when this is when theta is greater than 360 and falls in the first quadrant. Now if theta falls in the other quadrant 360 plus phi and the phi falls in the second quadrant, then you need to remember all the previous signs and write the appropriate signs. Okay, prefixed with the sign. So now what about when we have, if we have, we can say that 360, this angle 360 is n times of 360. So if you have to represent, I'll say sine of n times into 360 plus theta will be how much? Will be nothing but sine theta. Cos of n times into 360 plus theta will be cos of theta. This provided theta is, this is provided. I'll write the last value, then we'll write provided, sir. Okay, 360 plus theta is equal to tan theta. Here theta greater than equal to 0, less than equal to 90 degrees. Okay, this is how you're supposed to able to find the values of the trigonometric ratios. Okay, so this is all in this particular session. So let us summarize it. It's nothing. In this particular session, we have learned about trigonometric ratio for all types of angles. So all types of angles, when we have in this particular triangle, in this particular quadrant, first quadrant is the first quadrant. Here theta is, we have studied that theta is greater than equal to 0, and less than equal to 90 degrees. Here sine is positive, tan is positive, and cos also is positive. Here when theta is greater than equal to 90 or less than equal to 180, then sine will be positive. Okay, so here it will be greater than 90. Okay, I think in the previous slates also I say greater than equal to. If sine is positive here, even when it is equal to, it will be still positive. Okay, now here theta is greater than, so even for equal to, sine will be positive. Okay, but if it is equal to in this quadrant, then it is actually positive for cos also. So greater than 180, less than equal to 270 degrees, then here tan is positive. And here if theta is greater than 270 but less than equal to 360, then cos is positive. Okay, this is the summary. Okay, so that was it in this session. Please like, subscribe, and share. Okay, thank you. Bye.